Well, thanks everybody for being here and the invitation to talk. My family's first started dealing with marsh migration back in 1907 in the Chesapeake Bay. I've been studying it in the context of ghost forests since 2001, and that long history with the topic has led me to two conclusions that I think might be relevant to this group. The first is that the spatial scale of marsh migration is enormous, regardless of whether we try to facilitate it. In other words, it's inevitable. And in fact, most people historically have viewed it as a negative thing and tried to prevent it. Yet we still have big ghost forests, agricultural fields that have converted to salt marsh, etc. So I would say the facilitation is not necessary to ensure large areas of marsh migration. I think that's inevitable. But the second conclusion is that the real benefit of facilitating marsh migration is to improve the quality of the marsh that we're getting. So you can see in this picture here, marsh migration has been inevitable. Um, Large areas of forest have converted to marsh, but the quality of the marsh isn't particularly good. There's ponds close to the forest boundary. There's patches of Phragmites, and in other places it can look worse than this. And so I guess I would like to try to im- uh, move the conversation a bit towards using facilitation not to create wetlands, but to make the wetlands better. This is a picture from the eastern shore of Maryland. In the northern part of the Chesapeake Bay, we tend to have really big areas of marsh migration. It's fresher water, brackish. So Phragmites tends to be a problem. Ponding tends to be a problem. This is a picture closer to home. This is the Catlet Islands, part of the Chesapeake Bay near system, very close to VIMS. In the southern part of the Chesapeake Bay, like where this picture is taken from, marsh migration tends to be more spatially limited. Smaller patches of forest are converting to very much salt marsh. But because salinities are higher and the marsh migration areas tend to be better connected to the surrounding water bodies. Um, there tends to be, I think, less ponding, more native vegetation, things like Disticula spicata and Spartina patens, sometimes even Spartina alterniflora, rather than Phragmites at the marsh forest boundary. And then I just wanted to show one more picture. This is from the eastern shore of Virginia, Accomack County, showing that marsh migration, of course, is not just happening in the forests, but also agricultural fields. And I'm highlighting this picture because it shows some levees or small berms or small levees along the perimeter of the fields. And even though those berms and levees are there, there's still the development of a salt marsh behind them. Our work at VIMS has shown that marsh migration at least has historically compensated for marsh loss since the 1850s. There's actually been a small gain in marshland since 1984 based on Landsat imagery. The area of marsh expected to form over the next century is a similar order of magnitude to the current marsh area in the Chesapeake Bay. We actually don't think it will completely compensate for marsh migration in the future, but it's certainly a large component and large determinant of what our marshes will look like over the next 50 to 100 years. So far I've painted marsh migration as pretty successful, but there's also other examples where I would consider it a failure. This is a picture from near the Blackwater Refuge in a place called Beach Ground Swamp, where forests had retreated by 40 meters per year, averaged over the last 40 years. So that's almost 2 kilometers of retreat since Landsat imagery started. And the problem in this case is that the trees have died, but there's not much that's taken their place. There's lots of Phragmites in open water. And I think, like Karen highlighted in her last presentation, which was located very close to this site, that's where facilitation can help us. It can help us make the marsh that's migrating in higher quality. So I figured in our short time, I would show you two examples of projects that are in the very beginning stages. These aren't necessarily even going to happen. They've been proposed and we've started collecting preliminary data. but I think they illustrate some neat ideas on how we might use facilitation to improve marsh migration. The first is from Machcomico State Park along the York River in Virginia. Um, the park has a very narrow marsh boundary. Um, just a little bit of high marsh left. It's eroding pretty quickly. And it doesn't really have anywhere to migrate inland to because there's a thick band of loblolly pines, young, early successional loblolly pines that are shading out the understory. The park's interested in facilitating marsh migration for two reasons. One is the premise that we're all on board with, which is creating wetlands. The other premise here is that their main interpretive area is up a hill just to the north of the photograph, which has some of the best views, I would say top five view in all of Virginia, but it's threatened by the growth of those loblolly pines. And so the idea here is that if they removed or thinned some of the loblolly pine trees, they could both improve their views and, as a bonus, create extra marsh. Um, the on the ground that looks like this, you can see the band of loblolly pines. There's basically no marsh growing underneath them, very little transitional vegetation. But there's a clue. There's some natural gaps in the forest, um, and in those natural gaps, there is actually beautiful marsh and transitioning vegetation, both shrubs and native Spartina patens that are occurring at the same elevations and salinity levels as the forest next to them. So that gives us hope that if we remove the canopy elsewhere, we could facilitate the development of new marsh. So we've collected preliminary soil, light, and vegetation measurements. Probably the most important one here is that there are abundant saline wetland plants, salt marsh plants in the area at the right elevations and salinities. And whether or not you have the saline wetland plants doesn't depend on elevation and salinity. Rather, it depends on light availability and the presence of the forested canopy. And so if we take some of the lessons learned from Joel Carr's presentation, to facilitate marsh migration, you have to have the correct elevation and salinity, or else when you cut trees or do some other manipulation, things just grow back. And I think we've got those correct conditions in at this site. The other project I wanted to introduce you to is something that I've been proposing to the Guinea Marshes Wildlife Management Area on the Severn River, also in Southern Virginia, down in this box. This map is a map of all the low elevation levees, call them berms, or we call them ditch banks here in Gloucester. In the Chesapeake Bay, most of these, well, almost all of these are unmapped, mostly unknown features that aren't necessarily blocking marsh migration completely. Many of them have marshes behind them, but as I um, speculated before, the marsh behind those barriers is often less healthy than the marsh in front of the barriers. And we've characterized the influence of those berms on the marsh in a variety of ways: vegetation, hydrology, soils, with the premise that we could target target some of these berms to breach to enhance the health of the existing marsh. So Guinea Marsh's Wildlife Management Area to me is a really useful way to study how to do those breaches because the berms are so old. Some of these actually show up in maps from the 1850s. Because they're so old, lots of them have already been breached. So in the picture here, there's a tidal channel that's connected to the Severn River that's breached the corner of this berm or levee, and the marsh behind it, or the land behind it, has largely converted to marsh. It was marsh before the breach. It's still marsh now, but what this natural breach allows us to do is to, if we look at enough of these natural breaches, to be able to speculate if you create a breach that's say 5 meters wide or 1 meter wide, how much in what area of marsh is going to be enhanced by that small breach? If you breach 1 meter, do you get 10 acres of marsh? Do you get 100 acres of marsh? That sort of thing. It allows us to study some of the other factors that might be um, associated with the success of berm breaching, whether it be connectivity to tidal channels or some characteristics of the uplands behind them. And so we hope from this study that we'll be able to identify not only um, berms that are preventing marsh migration or um, leading to less healthy marshes, but that we'll be able to identify the berms that will have the berm breaches that will have the biggest impact. So those are some observations from the Chesapeake Bay and some preliminary projects that we're just in the planning stages of. And I figured I'd just leave you with this conclusion that sea level rise will lead to inevitable loss of coastal forests and marsh migration, but science and management efforts can increase the odds of healthy marsh migration and perhaps in ways that are conducive to maintaining rural flood defense. And finally, I'll leave you this picture. I love it. It's a picture of a marsh on the eastern shore. One side, there is an old levee going down the middle of it. One side of this picture is a marsh that's thousands of years old. The other side is a marsh that essentially was created by breaching a levee. And you'd be hard pressed to tell the difference. And in fact, uh, the marsh that's only 20 years old is on the right side, and if anything, it might look even a little better than the marsh on the left. So I'll leave you with that as motivation for how we can use facilitation to create more ideal marshes. Thank you.
Okay.